And we are live, and everybody should be seeing my first slide. So this is a 2020 opening of an event, I guess. So welcome everybody who is already there. I would say let's wait 30 more seconds to see if someone is joining a couple of seconds late. We're still here, still here. All right, let me begin this presentation and this introduction for tonight's event. Tonight's event is a joint event between Reactive Amsterdam and Kotlin Amsterdam meetups. Even though, I've been wondering, it doesn't make a lot of sense to still have these names, geographically tied names like Amsterdam in the name of a meetup. Now we're all virtual. So anyway, we've been doing a lot of successful collaborations lately, and I think it's really cool. There's a lot of overlap in our interests, and so it's a win-win for everybody. And let me start the presentation. Our speakers tonight. She is Mary Grigleski, tuning in all the way from Chicago in the US. So for us in the Netherlands is what, 5:30, is about 10:30 in the morning.
Yeah.
And her talk is Thirst-Quenching Streams for Reactive. I'm really looking forward to this to her talk later. And before I'd like just to spend a couple of minutes on tonight's sponsor, which is Lunatech. Is a French and Dutch agency, and personally, I am really happy to work with them. I really genuinely like them a lot. We've been working together every now and then for the past few years, and they really are a lovely bunch of people. They care about the community very much. They are these pictures that you see on screen are taken at the last Scala days that happened in 2019 when live events were still possible. And so it's a funny story. What you see on screen, the red dog is their mascot, and the idea was that for every person that would take a picture with the dog, they would donate €1 to a charity of their choosing. I really like them as a company. And in fact, I would like to show you a very short video about it. And for which video, I need to switch very quickly to a Chrome tab that I should have ready. Excellent. So let me put this full screen and then a little minute. Nice, that was it. They really, I really like them again, and I would invite everybody to check their website and their skills and what they do. and maybe you find something interesting there. And this is the moment where I would love to pass the microphone to Mary, our speaker.
Okay.
You're not sharing your screen yet.
Oh, yes, that's right. Sorry.
But so in the meantime, just let me introduce Mary very quickly. We met for the first time at a conference in Rome. What was it, 2018? Or maybe 19?
19.
19, yes. Oh, the last golden year of conferences, was it?
Yeah, that's right. Yeah, in Rome.
And in Rome, yes, exactly.
Yeah.
Which was in fact, Rome is my hometown. So it was a very special conference for me. And I was so lucky to meet such awesome people like Mary and stay in touch with a few of them. So yeah, really good memories from them.
Yes, that's right.
And all right, so you see now Mary's screen has come, and Joost and I are going to go under the radar, and I'll leave you to Mary's presentation. Thank you very much, Mary, for being with us.
Thank you, Fabio, and thank you, Joost. I really appreciate you having invited me here to speak at Reactive Amsterdam. It's like the premier meetup group for all things reactive in the whole world. So yeah, thank you. Really appreciate this. And as Fabio had given such a nice introduction, Fabio and I met in Rome, and just great conversation. And as you can tell, this is a very interesting topic. And of course, your meetup too, it's all about reactive. So I'm really feeling so honored to be here. I hope it is okay to actually, this particular presentation is maybe a bit more introductory. I just have been doing this for a while, and because of the timing, I decided, okay, I can also do this talk, but I'm hoping too, it's a bit of sharing of some code too, in addition to just talking. But the talking part too is that I'm going to just, talk about some things that are happening in today's world, kind of beyond what my slides have been, because those things are kind of being worked on right now. I just have to apologize, didn't have a chance to kind of do a more polished job on the slides and then about what I'll be talking about. But essentially too, I just want to talk about something on Project Loom, for example, and Quarkus and things like that that are relevant for the reactive world. So, okay, so I am,
Nice.
Yeah, thank you. So I'm a developer. Yeah, thank you. So I'm a developer advocate at IBM, and then I'm also a organizer of a few technical community groups, and primarily the Chicago Java Users Group. So also too, I would like to invite you to our party, which will be this Thursday. See, the thing is, I'm already excited and wanting to talk about the party first before I even present my talk. But the thing is, just don't want you to forget about that. So want to invite you there. And so now I'll begin my presentation. As such too, I'm as I was talking with Fabio, because this is an open meetup group, so maybe some folks may be new to Reactive, so I'll take a moment to talk a bit about some basic concepts. So pardon me if you're already expert in this area. So as such too, for Reactive, it has been a buzzword for quite some time. But I feel too, even personally, I feel it's been the buzz kind of got heightened up in more like 2-3 years ago, I'd say. But it started off in more like 2010 or 12. And that's the time when Netflix started releasing their RX Java Reactive Extension back then. Because Reactive, as such, we all know, is not new. And essentially, too, even going back in history, I think there's the basic computer, but actually they were using hardware interrupt, and that was like back in the early days of computer that was already using kind of reactive technology. So as such, we all know that reactive has many representations, so to speak, about it. So first and foremost, too, we have the reactive programming part, and then reactive systems, and then reactive streams. And then there are streams, there are events, everything's that's kind of tie into this reactive concept. And it is not new. The thing is, too, in the 70s, Erlang became popular with its actor model, which is now has been adopted by, or kind of used by the Akka framework library, as we all know it. And as such too, it's reactive. It's I'll go into a bit of details, assuming for some folks who may be new again, so pardon me if I'm repeating, about reactive systems, the Reactive Manifesto, and then here there's also reactive streams. Reactive streams are but like a specification that essentially outline how we should be handling asynchronous processing and back pressure, and in a non-blocking way. So as such, let me then also, before going into all this stuff, let's talk a bit too about reactive programming. And everybody knows too, there's a reactive extension, and this is the RX. And as I mentioned too, reactive became more kind of starting to get hot is because Netflix ported RX Java from rx.net. So the very early stage of the reactive extension came from Microsoft, and it was with rx.net. Then Netflix ported it to Java in 2012 or so, in that time frame. So now too, RX is still very popular, especially among like Android developers. But of course now I think there's also RX Kotlin, with Kotlin being the primary language for mobile on the Android platform. So as such, when we get to doing programming, and also too, a lot of times I've been asked by folks in the audience when they are new to programming, even though they have been programming for quite some time, they may be asking, how do we switch to doing reactive programming? And I would suggest that to learn about streams programming and also reactive extension, their operators, that would definitely be a good way, because it kind of gives some fundamental kind of understanding of how you actually interact with streams. In reactive programming, we all know we are dealing with data as streams, essentially, and that's actually also making use of the functional style of programming. It is not the same as functional programming, not exactly, because reactive, we are kind of talking about a higher level of abstraction, where the flow of your program is actually, everything is based on the state changes within your data. And then with functional programming, it's actually with the thread of execution. So a bit kind of lower level, if I may say so, for functional programming. So such is the difference. But okay, go back to reactive programming. We use marble diagrams. So these are like different ways of expressing events that are happening in a reactive program. And again, too, these are like fundamentals of a reactive kind of approach of reactive systems. So and as such, right, and my talk too were about thirst-quenching streams, because as such, in today's world, when we're dealing with data that's kind of like coming in huge volume in IoT applications, artificial intelligence apps, machine learning algorithms, big data, data science, those are really making use of streams instead of the traditional way of programming, in which we have data structures and everything. I mean, while they are good to help us, and that's how most of us, I'd say, or almost all of us, started learning programming using the traditional way of you defining your data structure and everything. Whereas like with streams, we're dealing with unstructured data because they can be coming at any point in time. And events-driven event system basically are signaling, indicating to events can happen at any time. So that kind of add in this kind of a surprise element to it. Anyway, with me kind of talking all these kind of off, kind of, same thing, but kind of been off, let's get back to the marble diagram. That's actually come out of the reactive extension. So again, these are just ways of expressing streams at the different stage, in time. So this particular one is the second one here is basically a perpendicular line. It indicates a stream that has a definite timeline to it. And then the third one has like a cross to it. The cross signifies an error event. And then over here to the bottom one is an open-ended stream. And let's take a quick look too at some introductory kind of operator. As I kind of talk about, when we work with streams, we're talking about operating on it. So in the reactive extension terminology, we are kind of talking about operators. Now, operators is not just applicable to reactive extension, but the thing is too, with the Spring Reactor or the Project Reactor too, they also have a large collections of operators, because the pivotal Project Reactor is also it's actually also developed by the same group of engineers from the RX Java 2, David Carnock with his group. So you find a lot of similarities too between these operators. And this is just a quick example of what an operator is. Like map is a very commonly used operator. It's essentially you define your functions, how you want to operate on the data. In this case, it's 10 times you multiply your elements by 10, your data. So then you see that in stream processing kind of expression, you'll see that the resulting streams will carry with itself results of 10, 20, and 30. So in RX Java code, or actually with this too, I believe the other syntax are the same for the other implementations of the reactive extension. So not just for RX Java, but in JavaScript, it's also being used in the same way. Kind of, it would be like observable.just. .just is a way of operating on your streams, like an input to your observable, which is your streams, and then do a dot map. You apply the functional operator to it, how you want it, and then immediately too, you do a dot subscribe. Is you subscribe, you're like the client. You're actually subscribing to something in the future that will happen in the future when during the time of coding. So in this case too, you subscribe to the output, but the output too will actually be displayed as over here. I'm using timber.d as just a display of what, however you want to set up this to. But in this case, it can be like output to a console. So then you'll see item 10, 20, and 30. So you can visit rxmarbles.com to get a more in-depth kind of a understanding of all the different available operators too. Now, then on to then about reactive systems. So again, this could be a repeat for some of you, but again, with reactive, we always bring up the 4 tenets of what it means to be reactive. First and foremost is responsive. Your system, application, everything needs to be highly responsive. So all requests coming in needs to be handled in a timely manner. And also too, your systems will need to be very capable of expanding itself, becoming very elastic, scalable. So if there are more requests coming in, so it needs to grow accordingly, there would be more resources to handle all of the requests that are coming in. Otherwise, too, what we will see is problems of back pressure in which you can have like an overwhelming amount of requests and there are not enough processes to handle them, then it will create this back pressure scenario. So any reactive systems will need to have very good mechanism to handle back pressure. And then if you are, you're done with it, then all of the resources should be returned back to the pool, or maybe you shut down something so then you don't, overwhelm your system and you can release your resources for something else. And then another tenets of it is the resiliency. So anytime if there are errors that occur, by leveraging on like a circuit breaking type of pattern, then you want the systems to bounce back in a very kind of non-interrupting way to the whole ecosystem. Or you can also have, for example, like ACA system that folks you're aware of, in which some nodes are down, then immediately too you have mechanism of spinning off new nodes to handle in the cluster to handle requests. So then like your overall responsiveness of your system do not suffer, the performance do not suffer. And then all of these two are basically enabled by a system that's essentially message driven. And then message driven is essentially you have communications between like two isolated components within the same ecosystem or like the same application, be able to communicate with one another. So message driven is that you have sender and receiver. So you send your request and you send it to a known address. You receive it, you know who is going to receive it, versus like a event-driven kind of scenario in which events are being admitted without knowing who the subscribers who will be interested in subscribing to it. So that's kind of the differences. But again, this is like the 4 tenets of the Reactive Manifesto. And so let's also take a look. Reactive systems too, again, is not new, and the problems have always been there. Essentially, too, we are trying to address problems in the concurrency space. I'd say, for me, I think among all of the computing problems that we are trying to solve in this world through computers, using computers, I'd say concurrency is one of the most challenging of all times, because we're dealing with multiple processes. We're dealing with data that basically are driven by different events that can happen at any time. I think, a synchronous way of doing things. And while the purpose is to kind of minimize your resource consumption, or kind of maximizing your resource consumption, and making it also very efficient too, so then there's no downtime, so you kind of really, utilizing your resources really efficiently. I think, anyway, to kind of trying to coordinate a systems of, makeup of different things, different approaches, different tools, different mechanism, it's always been a very difficult thing. So reactive comes out too, is this higher level of abstraction to try to solve this concurrency problem, dealing with multiple tasks all at once. And also too, over here is versus parallelism. Parallel processing, as we are aware, it's actually having like multi-core. You do need to rely on hardware to handle it. You are truly doing multiple tasks all at once, because maybe one core of your computer is handling a bunch of stuff, and another core is handling another task. They are being handled all at once. Whereas concurrency is we're dealing with multiple tasks all at once, but it can give you an illusion that they're happening all at once. It's because all of the switching in between to handle some of these processing. And of course, too, in the old days, too, when computers were simpler, because we only have single CPU or single core, there were concurrency, but all of the threads are being handled in the kernel level. That's why, too, you can tell, too, at that time it's not as efficient, because your main thread is can be holding up of all of the I/O. But now with reactive, it's abstracting all of these things. And also, too, some libraries, for example, like Vertex, would have his event bus to handle all of these. And essentially, they're still threading, don't get me wrong, but the threading is being moved to the user space versus holding up the thread in the kernel space. So that's what it is. So, all right. And let me kind of go a bit further. So there's reactive architecture design patterns, which I already talked about, like circuit breaking, back pressure. And then also there's interesting newer ways of design patterns would be like event sourcing. And that's without going into a lot of details, but essentially you want to capture all of the events, essentially capture all of the data through time. So then you don't actually need to store your data so much as it is storing the series of events and the state of the data over time. So then you can actually do a replay to see how the data has changed over time. But that's event sourcing in a nutshell. And then there's also CQRS, in which, again, I won't go into details, but they are also commonly used pattern in the reactive system space. Now, there are tons of other reactive systems pattern too, like among them could be Saga pattern, and also like eventual consistency. And those you can, I have a link to towards the end, in which you can get some understanding to a site that's written by someone that used to be at Lightbend, that wrote up a real good book on all of the reactive patterns. And now then let me get more into like streams. So in streams, we're talking about the models of push versus pull. So push is essentially, it's like in reactive extension, that terminology, an observable is essentially a stream. It's kind of hot. We call it like hot stream, because it's the upstream of the data will push, or actually I should say upstream data will then get pushed to the downstream. That's kind of a push model. Now, there's also pull model, in which downstream will pulls the data from the upstream. Downstream will initiate, and it's kind of subscribe in a reactive extension kind of terminology, will be a code observable. Is kind of, in some ways, it's like lazy. I pull the data and pull something from the source side that hasn't happened yet. The data isn't there yet. I'm dealing with something that will happen in the future. So just in some illustration, producer can be emitting data, and it kind of gets sent to the consumer, and without being asked explicitly too. It's more like, and I'll also kind of have one slide to talk a bit too about a true push model that's used by the OSGI. OSGI is the model, the module framework behind the Eclipse IDE, as well as a bunch of other applications. It's an older framework. So anyway, they have a push stream specification, and that's a true kind of push stream kind of implementation too. So okay, so that's that. And then there's also pull, which is like downstream, you initiate and pull from the upstream when the data is ready. And that's actually, I think a lot of the reactive streams is kind of utilizing this model of like a pull, and then you pull, and then the data isn't there yet, but when it's ready, it will get pushed to your consumer like that. So, so that's that. And back pressure, these are just some slides to explain, you get too many requests coming in, there are not enough processors to process it, then you create the pressure will kind of, you initially you have pressure going into the request, but it kind of turns back and then is essentially pushed back and kind of reverse the direction, back pressure. That's another kind of interesting picture that I've come across about back pressure. You get too much publisher, and then the subscriber just cannot handle it. So, and just some kind of point out too about these reactive streams, and essentially too, the goal of it is reactive streams is to promote interoperability. You can actually have different libraries kind of implement is a standard. You follow the guidelines in here, and essentially too, there are 4 interfaces. Now, the reactive streams doesn't have any implementation. It's just a specify the 4 interfaces. But don't let it fool you, because it's actually complex too, even though there are only 4 interfaces. So as you can see over here, publisher, subscriber, processor, and subscription. So if we take a little closer look, publisher, we have subscribe, and then subscriber has the on subscribe, on next, on error, and on complete. Now, essentially too, every time too is if to kind of make something happen with these interfaces, your libraries then will have to actually implement the subscription once you have a kind of relationship set between the publisher and the subscriber. So subscription is where back pressure support will happen in here. And then there's also a processor that's essentially is kind of such by the name is kind of processes what needs to happen in your stream processing. Now, a few popular reactive libraries and toolkits that support reactive streams too, and that's Vertex. I mentioned earlier is Eclipse project, and there's also Eclipse microprofile project. That actually it's more microprofile is more catered towards for folks building microservices, and that's what its strength is in. It's got evolved from I should say it's kind of derived from the enterprise Java concept too. And anyway, so it's a more lightweight library that handles enterprise level like microservices, and that's what its strength is, and also has very good integration with the open source Open Liberty library. Then that's an enterprise library. It's actually Open Liberty is the open source version of the IBM WebSphere enterprise server or application server, if you're familiar with that. So, and microprofile too also has support for reactive messaging and reactive operators through the use of the SmallRye Mutiny library, and that's a newer library that just came out recently. Initially, it was called SmallRye, but I keep the SmallRye name because it seems like on their website they still have SmallRye, and then they mention about a newer version, and that's Mutiny. So that's also a reactive library, and it actually has a more streamlined set of operators than the traditional like reactive operators that we're familiar with. And so that's essentially the goal is to kind of streamline it, and plus also too it has 2 types too of dealing with like much like the Project Reactor Mono and Flux. So they have the single wait, I kind of like forgot about it. I think it's just too much stuff on my mind. But anyway, they have like also like 2 types in which they handle like end 0 to like multiple elements in the stream, or 0 to 1 uni. That's right, and uni and how can I kind of forgot about it? And multi. That's right. So they have like the 2 types of reactive stream elements or streams that they handle too. Anyway, so that's that. And then there's Reactive Extension that we talked about earlier, which has multiple library implementations, including primarily we're talking about here RxJava, RxJavaScript, .NET, Python, you name it. It's implemented by almost all popular languages. There's Project Reactor from VMware. And of course, too, well, we're in Java, but I do want to bring up, too, there's Orleans. That's also a reactive library. RSocket, as we know, is a bit lower level, dealing with the socket level kind of communication. Is open source, open network, level 5 and 6 kind of protocol streaming. And then, of course, there's Akka, too. And so, again, this, oh, I'm so sorry. I meant to say, I already kind of brought up too. So these are the things that I already talked about. So I won't go into too much detail on this slide. But the thing is too, there's Spring Reactor, then there's Reactive Extension that I talk about. Essentially too, I would just give some example towards the end. But then there's also RxJava 1 and RxJava 2. And that's what I kind of found it was having. It could be a bit confusing in terms of when you're looking for information on the web. Sometimes it comes information, even though, okay, the basic set of operators are pretty much, RxJava 2 has more capability. But the thing is, too, what you find in the internet is that you could be looking at RxJava 1 specific implementation, and then some were RxJava 2 very often, too, and mixed with also RxJava 3. And the difference is that RxJava 1 doesn't have support for back pressure, but whereas starting RxJava 2, then it has support for back pressure. So it's flowables is what is being called in RxJava 2, and above is flowable. And you can actually have an observable, and you can also do like a to flowable to convert it to the version 2. Version 2 streams 2. And there's also Vertex. Now, I won't talk too much here, but just want to kind of point out they have their polyglot model and event bus, and also their vertical model too, which I have some code sample to show you, and also the Vertex runtime. And then, of course, there's also Akka streams, and I believe that folks here are very familiar with, I'm just assuming because, of course, Fabio, you are like an expert too in Akka, so I wouldn't be like talking way too much in here, but we all know the benefits of using Akka streams, and it's very capable, very sophisticated reactive library. And let me see, I am not, oh, I think, okay. And then there's microprofile, which I also talked about already. Primary focus is on microservices, and it integrates real well with Open Liberty. And then these are just some additional information too about microprofile, reactive messaging. Again, it makes use of the Mutiny library. But essentially, as you can see too, some diagram to illustrate is that it's making use of annotations. And the annotated methods are essentially connected by named channels. So we're making use of like attribute like incoming and outgoing annotations. And the channel is basically a name that indicating which source or destination of messages is used. And channels are really opaque string in here. And you can also see, and as this example show, is that you have method A annotated with outgoing to order this particular channel kind of name with order. Then it goes to the incoming, which order. So in this case is method B. Method B also has an annotation of outgoing to status, and that one in this case will go to method C, where it has annotated it has an incoming annotation of status. So that's kind of some fundamental of how microservice or microprofile reactive messaging works. And then there's RSocket, which I also kind of briefly spoke about, is a binary protocol for use on byte stream transports. There are four models to it too. Request and response. Fire and forget is request response 1-1, and then fire and forget is 1-0. And there's also request 1-N, request to stream, and also a bidirectional sustaining like channel too. Okay, so this is just a quick slide that I borrow from the Spring Run platform, and they talk about the Reactive Foundation support of the RSocket and also the founding members in here. Now, there's some additional info, which I talked earlier, was the OSGI push stream. Currently is at R7, and it implements self-implementing API, unlike the reactive streams too. And the nice thing about it is that you only need to kind of have a dependency on the OSGI promise. But other than that, there's no any requirement that you must use the rest of the OSGI specifications and frameworks for your implementation. So you should be able to then use the OSGI push stream and the promise together in your particular application too. So, and just some primitives of comparing the reactive, between reactive streams and also the push streams. Our reactive streams are essentially based on Java 9. I point out already, there is publisher, subscriber, subscription, processor that maps to push streams is a push event source, push event consumer to the subscriber, auto closable to the subscription. And one note to point out is that push streams is interesting, in which you're working with your streams, but you also have the mechanism and also the control over closing your stream to when let's say you're done with something. Versus in reactive streams, and you do a subscription, but you are letting the library or the framework to handle closing the streams, and so you do not actually have access to controlling the stream, closing it, for example, and you cannot do it in reactive streams. Whereas like push streams, you do. And then there's also the reactive streams of processor in the pipeline, and also push streams is simply the push streams interface. And okay. So that's that. And now then I can go, I think I have about 10 minutes or so, and I'll just go into talking about some sample use cases. Okay, and oops, go over here. Okay, now just a quick thing. Maybe I'll also point out too, and also, by the way, I'm doing a stream on Twitch too, weekly stream. So it's aiming at more like raising level of awareness of reactive, and through the use of reactive programming. Because again, like if I step back, right, reactive is such a kind of a big topic that covers so many things, and you can kind of go from many level up and down and all that, but everybody seems to be always like a programmer. You want to learn how to program it, and then how to do it. That's again was the question that I've been asked. And the thing is, again, dealing with streams, one of the best ways to learn how to operate on streams through the use of these operators. So I've been kind of doing this stream as kind of showing how to use some of these operators. So I'll quickly show this. But the thing is too, before I actually get to that, I also mentioned about I'll be making this a bit more like an interactive, or kind of more like some free-flowing ideas too that comes out. Not free-flowing as such as it is, just some new things that come up, which I haven't incorporated into my slides, is about Project Loom. So you may have heard of Project Loom. Somebody was saying that, well, can Project Loom overtake a reactive? Now, the thing is, I'm not that... I haven't taken enough time to study in depth about Project Loom and the use of the virtual threads and carrier threads yet. But the way so far from what I've read about, I believe that it's not so much as, reactive is going to be overtaken by Project Loom. Why? Because I feel reactive still, if you look at all of the libraries, they are a lot more handling data or applications on an abstract level. So it isolates you from some of the lower level concern. So in that sense is that reactive too, the library implementations is handling all of the stuff that needs to happen underneath. So I'm kind of thinking is that maybe reactive can kind of more like working like hand in hand with Project Loom's new virtual threads. Maybe it will be making use of some of these lower level mechanics libraries inside the reactive library, and that's what I'm thinking. You can correct me if I'm wrong too, but I think I would be happy to have some discussion. And also, of course, do we want to also follow the development and the continuing kind of conversation on this aspect? And I feel like we're living in a world, and we are like relying on all of the different layers to have things like work together and happen. So it's not like something just overtaking something, but it's more like, can we work together? Can we take the best of all of these layers and combine them to form a solution that's the most efficient, the outcome? I think we should focus on that. So anyway, before, it was just before I forget, I thought I should bring up Project Loom. And again, after this, we can have some conversations if you like to talk more about Project Loom. So, okay, so now with that, let me kind of take a look, with some of the things I've done to with dealing with. Okay, over here, I'm like doing different things, examining the different ways of doing reactive operators, right? So the thing is too is that with reactive operators, as we know too, it's kind of main thing is, or there are different categories of reactive operators. So first and foremost, there's like create. You can create things and you can do transformation on your streams. And there's also like utility and also like time sequence stuff. And not only that, there's also, well, actually, I didn't have a slides with that, but like I said, there's create and then like time sequence, there's utility, there's transformation, there's also the other thing, I'm just trying to remember. You know what? I really have to like kind of apologize. Sometimes I'm, okay, let me kind of get my notes up. So there's also, yes, transforming, and then there's combining, of course. Yeah, there are different ways, you deal with data. There's always a need to combine, stream data coming from different streams. There's also conditional ones and mathematical operators and some connectable operators too. So those are kind of like a broad category of all of these operators. And then there's also like scheduler that helps, with anytime you work with asynchronous processing, we always rely on some scheduler. So RxJava also has its own scheduler. But anyway, let's take a look now. So quickly, let me kind of show a quick thing about over here. So a simple case of an observable. This is using RxJava 2. So just when we talk about observable, we do a .just, and that will essentially compose, take the input, from a set of kind of elements, and then construct your stream. So in this case, just is, as you can see in here, is just, okay, let me just explain it a little better, right? It's just basically, it does not operate by default on a particular scheduler as well. So the parameter you take in will be elements in your stream. So in this case, I take this stream, doing a dot map, and to uppercase is what I'm trying to do. Then we subscribe, and the subscribe essentially just saying that, okay, take whatever output you have and then display it accordingly on the console in this case. So now let me then take a look a bit more too. Also, like looking into like single observable tests in this case is basically there's also an observable, as I mentioned, it is essentially your stream in an Rx extension terminology, that umbrella. So there's also a single observable. Single is essentially dealing with a single element. So in this case, this one is single.just. I take hello friends. And basically, I'm using a, in this case too, is that I will output it and assign it to a disposable. This disposable essentially is also an observable. The difference is that disposable, as the name implies, it means you can throw away. Once you kind of operate on that, it's ready to be disposed, kind of thing. So in this particular case, I show you an example. You can do a test single. This is my string, and I can then do, or actually I should I should just say single.just, right? I take the string and I basically do a delay, the delay, and then I do a subscribe with in here. So this subscribe with, then now I'm using a new disposable single observer, and I basically specify, right, with my subscribe with, I'm also doing a instantiating my disposable single observer inside, and then doing and act on it accordingly. If it's success, then I will print it out. If not, then I'll print out the stack trace. And over here too, then I also, in this particular case for testing purpose, I also set a delay by like 3 seconds, because it's just to simulate the situation. So then this will kind of operates, and output is, whatever it is. And then at the very end, then I can just do a dispose signaling that this stream can be closed. All of the elements can be closed like that. So, okay. So that's a single observable. But there's also another observable called maybe. So maybe, in this case, the usage is, you can see too, is similar to the other single. But essentially, I take the input and doing all of these things. And the maybe, what it is actually is that maybe is dealing with, it can handle also like null elements too. So if there's nothing, it outputs like something like nothing in this case. So that's maybe. And then there's also interesting too, is that there's also not only can you take the observable from an array, you can also say doing like a from array is like you take from an array of elements and they will convert it to a stream. But there's also a what you call like a from callable. So this is an example of a callable, meaning that I can actually take the stream based on output from a callable. From, in this case, a simple case is that I've set up a static inner class that I'm basically say observable dot from callable. I basically have this class that actually has a call method in there that essentially what it does is return the name of my current thread as a test. So you can see too over here in my observable, I can do a from callable, and that I can essentially take from my sample callable inner class, and then now this is kind of getting a bit tricky, right? But then as you can see too, it does look at like how elegant it is, right? You should be able to do this call within like a few lines, versus if you kind of do it in the traditional way, non-reactive way, yeah, you can certainly do it too, but probably will require reflection and doing all of these things to kind of take care of a lot of stuff, right? So over here, using like Reactive Extension as an example, you can see it's actually quite elegant. You can, again, do this observable doing from callable, and over here too, I basically just want my first three elements. I can just do a observable.take, and take 3 is like the first 3 elements. And then I can subscribe to the result and append all of these results too. So now I don't think I would have enough time to be running it, because my system, if I try to run it, execute it, it kind of takes a bit of time. So I'd rather maybe go into another set of examples too. Now those earlier ones I was just showing you were more reactive operators. How do you use it? But now let me go into talking about Vertex too. Vertex is slightly different, and again, too, Vertex it makes use of its event bus, and I will actually want to kind of go back to here to show you. So again, this is just like I'm showing these streams in like different library implementation of like stream implementation. How do you operate on it? And Vertex again is a library, and I wanted to highlight to Vertex about why I feel it is important. And we should pay attention, because it is quite like simple to get started and use it. All you need to do, especially, it's so flexible. You can actually write your code in different libraries using different languages too. Java, Kotlin, you name it. And I have a quick example to show you. You can actually have that participate in your Vertex runtime too. Now, right now, too, these examples are not utilizing the cloud, but you can also like deploy these to the cloud as well. But for now, for the example, focusing on reactive, I'm only doing it locally. So I know I'm like over everywhere, but or kind of all over the place. But Vertex, right over here, basically Vertex is also the engine, the reactive engine behind the scenes of Quarkus. Quarkus is a newer Kubernetes cloud native ready framework. And the nice thing about it is that it's very efficient, and even like during your compiling stage in your build, in case it will actually trim down your executable. Its goal is to is essentially helps with your containerization in the new cloud development, cloud native environment in Kubernetes, especially. So, okay, so quick note too about Quarkus, and as you can see in this high level diagram, is that you have your application going to your routing layer. In the Quarkus application, it will basically be handled by Vertex underneath the hood. And so Vertex is the ones that's handling all of the request and the response, making use of his event bus. So, and like I said, over here, a quick thing to want to point out, right? Is event-driven, asynchronous engine, and also polyglot in nature. So just wanted to point that out. And again, too, this particular example here is a polyglot use case of Vertex. And that's what in my particular code, I wanted to just explain in a diagram. I'm having an API vertical. So vertical is the deployment unit, like model, so to speak, in in Vertex. Much like ACA and actor model, but Vertex is vertical. Though not exactly the same, but the vertical works closely with the event bus too that Vertex has. So you can, in my particular example, I have different worker verticals that handle different things. One written in Java, another one in Kotlin, and then in JavaScript. And basically, there's this Vertex event bus that handles all of the routing in between my main vertical and to all of the worker vertical. My main vertical will act as an API gateway. So if there's routing, the routing, I set up my router, so requests coming in will kind of direct to each accordingly, is what it is. So let me then go back now. So I figured that would be good to just explain a little first. And although yes, so I'll go back. So quick thing too about this API vertical I show you, I can just extend the abstract vertical. And then over here too, it's just a whole bunch of stuff, but I'll have this code on my GitHub too that you're welcome to look at. This happens to be a project that I'm also working on my Twitch stream. So if you're interested, probably I'll restart this one in the new year because currently I'm looking into operators. So, so over here too, basically override the start method. And essentially too, Vertex can also handle the configuration. So I basically take from my property file, like a simple JSON file, quick thing. So JSON file is just specifying my port number, my delay, all these things. So let's go back here. Then I set up my configuration. I retrieve my configuration information. Also set up a listener so that if any changes in there, I can immediately update it in memory without me having to kind of need to restart my Vertex runtime. So over here, so that's that. So just a quick thing to show you. And then basically too, also if everything all goes well too, then I also will set up my router. Anytime too with Vertex, you want to set up a handler. So for example, with a web application, I set up my CORS handler for some of these cross cross boundaries, right, of domain boundaries kind of handler. I can also set up my router to, or I have to set up my router to in any web application to handle requests coming in and redirecting them accordingly. So over here, this set of direct code is what I'm doing. And then I also set up like a sock.js bridge options in here because that's for like managing my conversation between my JavaScript and also with my Vertex runtime in here. So, all right, so, but please do not pay attention to some of the red. I think I just have my Gradle, the library, not set up correctly, so it can't find it. So that's why. Okay, so just also a very quick thing. As I realize I'm kind of a bit over time, but just to show you too, in order to deploy your Vertex, all you need to do, you kind of have, you'll need to do over here is doing a Vertex deploy vertical. Then you point to your class, that particular worker vertical that's implementing that. You can just deploy vertical and then give it the name of your class, and then also then pass in whatever you can pass in your options to that particular vertical. And you can then immediately use an Lambda and kind of specify what to do if there's success or not success. In my particular case, this particular example is that I'm also keeping track. So deploy verticals here are like metrics that I keep track of my call, in the runtime thing. So now that's for Java. So as you can see too, to call a Kotlin, all you need to do is also deploy vertical and give it the name, and basically then essentially doing the same thing. So now you will also be wondering then what to do with JavaScript. And that, guess what? It's the same way of how you can deploy it from within your Vertex. Now, you also will be wondering, well, then how do you actually start your Vertex? So over here too, the start, as you can see, I think I skipped over that part in which I set up all of these things. And this is the part that I actually start my Vertex. So I basically will do a Vertex, create my HTTP server, and then basically chain my requests, set up my request handler, and then listen on the port. And then accordingly, that's when I kind of tell all of my workers to start working, is what it is. So as you can see, I mean, this is just a quick kind of scan over how to use Vertex, as part of Vertex also supporting streams and all that. So I hope you are finding it useful. And I know I'm kind of running out of time. It's probably dinner time at where you are. So I want to respect your time, and I want to kind of go back to my slide here. And just want to thank you all for coming to my talk today. And I know too, it's kind of nearing the holidays. So if you'd like to stay in touch with me, this is how you can stay in touch with me over here, the top here. Follow me on Twitter, my GitHub, and also I have dev.to. I also have a site for writing blogs, which I promise I'll write more blogs. Plus, I'll also be publishing on the Java Advent calendar in a few days. I actually, in fact, will be talking about reactive operators, just a kind of an introduction, and also compare it with the mutiny too, just in also introduction. So, and then that's my profile on developer.ibm.com. Also some additional information, and please subscribe to the IBM Java newsletter if you like. There are other topic areas too of various kinds of newsletter too. And you are welcome to join my Discord server for continued discussion too. And I believe this is such a rich topic. It's basically we don't want to like stop talking. So, and this is the IBM Cloud to sign up for a free tier account. I will kind of have this slide to give to Fabio, and you can also get it from him. Also a set of Reactive Streams resources. And also my live stream on Twitch, and that's on Wednesday. Chicago time is GMT -6 at around 12:45 or 1 p.m. on the IBM Developer Twitch. And with that comes to a close. And thank you so much again. I think I am 5 minutes over time. Thank you so much for your patience. I appreciate. Thank you. Really appreciate. So yeah. So yeah, I probably will go back to here if folks wants to copy anything. But thank you so much.
Hey, thank you, Mary, for your nice broad overview. I think you covered quite a lot of different frameworks, and it's going to be well, very helpful when I need to consider my options at the next time I need to solve a problem. Yeah. And I also liked the examples you showed at the end. That sort of makes it a bit tangible for not just a superficial in the air kind of talk, but actually.
That's right. Yeah, thank you. Yeah, I hope that was useful with a more polyglot example. That was also intriguing to me, so I started working on it. And so yeah, yeah, hopefully it was useful. So
yeah. So I asked for some questions, but I haven't received any through the comments, so I made up some of my own.
Okay.
Yeah. Can you tell about any experiences with trying to migrate from a non-RX environment to an RX application?
Oh, to migrate. Wow, from
so you have an old application which is non-RX, and somehow you need to turn it into an RX thing.
An RX thing, yeah, that's right. I think that's a very interesting topic, and in fact, I feel that's like one of the potential power in reactive application, especially like legacy application, monolithic. How do you turn it to reactive? Reactive itself, I feel, is very conducive, right? It's kind of a nice, it relates so well to microservices. The concept of, kind of what you call that? Oh, I kind of keep forgetting words today somehow. But it's kind of the not tightly coupled, right? Loosely coupled. So it supports that reactive. The concept supports that well. Works well with microservices. So I think definitely too for reactive. I think first and foremost too, you do need to understand your application well, and then see how you can break down, let's say, an older legacy application, identify some areas that currently you're doing some monolithic, traditional synchronous style of processing. Can you identify some of them that maybe have some high volume, for example, order entry, I think is a good example, like your order entry system, because it involves so many other external components. You can actually turn that into more like a reactive streams type of application of, you can be taking multiple simultaneous orders. They are actually implementing as streams, and then each stream too, each order you need to submit to your payment, for example, payment provider, things like that. These external services you can probably implement kind of using a reactive approach to solve this kind of problem, I think. And then, of course, you have order that you're also connecting, you're talking to your supplier to delivery side. I think, in a kind of high level sense, I think you can kind of use those. But how to do it? I think then you have to identify again your data. What exactly you're expecting in the data? Can you handle those as streams of data and then operate on them accordingly? I think like kind of using some of these operator approach of reactive extension, I think will be kind of some ways of doing it. So I hope that makes sense. Yeah, it's kind of a bit of a high level, kind of hypothetical kind of thinking on my part that can be done using reactive streams approach to solve problems and kind of make your resources to be very efficient, kind of asynchronous. Yeah. So yeah, I hope that answers your question, Joost.
Yeah. Okay. Cool. Nice. So I think you say that your experience, you need to decouple, and you must be able to decouple to be able to migrate to RX.
Yeah, that's right. Like the decouple concept is very important. Yeah, that's right. Yeah, that's right.
Okay. So a bit more personal question. How have you been faring through the pandemic?
Yeah, thanks for asking. I think I'm doing well, keeping busy. I think I'm a developer advocate, so I'm not just like doing the content part, but there's also event organizing, right? So those things keep me busy. So I have to say, it's weird to say, yeah, the work has kept me busy. So yeah, that's not too bad at all. And yeah, I'm actually finding myself a bit busier than when I was traveling, even though I really miss the face-to-face interaction. That's something I really miss. But having like online, doing it on on like social platforms, and that's helping. So is not too bad, I'd say. But I am still definitely, no doubt, missing the in-person opportunity that otherwise I can have, when it's normal, during normal time. So yeah. Yeah, but thank you for asking. Yeah, I cannot wait until we can all travel again. Yeah. So how about yourself? Yeah, how about Joost and Fabio? Are you feeling like it's getting real tired of this lockdown?
Well, I'm starting to forget what real people look like, but the rest is working sort of fine. I have a job which I can do from home without any effort. So
yeah, that
Interesting enough, Joost and I are in the Netherlands, and the Netherlands just today entered a new strict lockdown. So, like, all shops are closed, and back to homeschooling for the joy of our parents, friends like Joost.
Yeah, that's right. Yeah, that must be hard. I know. Yeah. Yeah, it's kind of, hopefully now with the vaccine, I think maybe will help to now really solidly, concretely reduce the number of cases, and we can really go back to normal soon.
Yeah.
soonish.
Soonish, yeah, that's the word to use. Yeah, and actually, while you are talking, please continue to talk. I'm thinking I mentioned about CJUG. We're having a holiday party, so I want to invite you to. I think I have sent that over to the information to Fabio, and but I want to also just quickly kind of print this out. Okay, it's kind of interesting when I have to move things around. So pardon me for I cannot move it over here for some reason. Oh, here we go. Okay, so this is just an Eventbrite too. I just wanted to show. So we have like a year-end celebration, Chicago Java Users Group. I try to accommodate all of the time zones too. So I'm hoping 3 p.m. us, it would be like 10 p.m. your time. So it isn't like too late, hopefully.
Yeah.
Yeah. So I believe I've sent the link to Fabio, but let me do that again, and to Joost too. So you are all welcome to join. It will be on Spatial Chat, and it's a two-dimensional proximity chat platform. Is very interesting. Yeah, have you used it? I myself, I really like it. Last time at the JLove conference, it was really great talking to everybody. I think it's the closest you can get, in an online format kind of thing. Yeah. So yeah, so I will send that to you again. I hope to see you there, and everybody can join too. It will be kind of fun, and yeah. So
Yeah.
yeah.
Thanks.
We'll
Thanks
share
for
it in the
this
comments.
invitation.
Yeah, you're welcome. You're welcome. So yeah, yeah. So yeah, yeah. Great.
Okay.
Cool.
Yeah.
It's been very nice.
Thank you.
I think it's time to end.
Sure. Yeah. Yeah.
Yeah. Thanks, Mary, for being with us, and thanks to everybody for tuning in. Of course.
Thank you.
Wishing you all a very happy New Year.
Yes, it's the same. Yeah. Thank you. Yeah. Happy New Year. Happy holidays to all.
This is our last meetup of the year, so yeah, hopefully 2021 is going to be a fresh start for a lot of us.
Yeah. Thank you. Thank you. So.
Cool. Then yeah, logging off. Thanks everybody again, and see you in 2021. Bye.
Yeah. See you next year.
Thank you. Bye bye.